All right, let's talk about it. We are tackling a true giant of mathematics, a chapter that, let's be honest, often feels like this unclimbable mountain: integration. If you've ever looked at it and just felt completely overwhelmed, you're so not alone. It's often thrown at us as this huge, messy topic, but we're going to change that today.
So let's just get this out of the way right now. Is this subject actually as difficult as everyone says it is? So many students feel that way, and honestly, that's a totally understandable feeling, especially based on how it's usually taught.
And this is where this amazing analogy comes in. Think about a food you used to hate as a kid, maybe something like bitter gourd or Brussels sprouts. Was the vegetable really the problem, or was it just how it was cooked? The source for this explainer makes a fantastic point. Maybe the problem isn't integration itself, but how it's been served to you.
All right, so here's the game plan. We're going to see this topic as an acquired taste. Then we'll get into what integration really is. It's about building, not breaking. After that, we'll go over your essential toolkit, learn the direct method, then the art of substitution, and finally, talk about the path to really mastering this thing. Okay, so first up, this whole acquired taste idea. Just like that vegetable can actually be delicious when it's prepared the right way, a topic like integration can become not just something you can get through, but something genuinely interesting. But only when it's presented in a clear, logical way. It's all about the approach.
So to really get what we're doing here, we have to get to the core concept. Just for a second, forget all the complicated formulas and symbols. Let's just think about what integration is fundamentally doing. Think of it as an act of creation, of building something up.
You know, the easiest way to picture it is to imagine you're putting something together. It could be connecting puzzle pieces to finally see the whole picture, or maybe you're assembling a bunch of tiny parts to build a complete robot. In both cases, you are integrating. You're just taking small, individual things and summing them up to create the whole shebang.
And that brings us to its official name, the antiderivative. Now here's the crucial part. If you understand differentiation, the process of breaking a function down to see its tiniest changes, then guess what? You already get half of integration. It is simply the exact opposite process. It's all about building that function right back up again. And look at this, it shows it perfectly. On the left, differentiation takes x squared and breaks it down into 2x. And on the right, integration takes that 2x and builds it right back up to x squared. They are literally two sides of the same coin. Oh, and that little plus c? That's just a constant, because when you differentiate, any constant number disappears, so when you go backwards, you just have to remember it might have been there. Understanding this inverse relationship is your first huge step. All right, so we get the concept. Now what do you actually need before you even start? Let's talk about your toolkit. Before you can start cooking, you need your ingredients ready, right? The source calls this our raw material, and trust me, without it, you're just going to have a hard time.
Okay, these are your two non-negotiables. First up, you've got to be comfortable with your basic derivatives. You don't need to be a calculus wizard, but the fundamentals have to be solid. And second, and this one is huge, you absolutely need your trigonometry formulas and identities down cold. So many integration problems are actually just tricky trig puzzles in disguise.
Okay, toolkit's packed. Let's take our first step with the most fundamental approach there is, the direct method. And the beauty of this is that it's all about using what you already know. So here's the cool part about this method. You're not learning anything new here. Not really. It's literally just reading your list of derivatives backwards. I mean, if you already know the derivative of log of x is 1 over x, then congratulations, you automatically know that the integral of 1 over x is log of x. It is literally that simple. And you gotta love this piece of advice from the source, which kind of uses a cooking analogy. It basically says, simplify to your ability. What that means is, once you have the main answer from the integration, how much you clean it up or simplify it is totally up to you and your comfort level. The real goal is just to get the integration part right. Okay, so the direct method works when things are simple. But what about when they're not? What happens when problems get messy? Well, we level up our strategy with something called the art of substitution. This is less about just applying a formula and way more about strategic thinking, kind of like being a detective.
So here's the big idea with substitution. You're basically hunting for a function and its derivative, both hiding inside the same problem. Once you find them, you swap out the complicated function with a simple letter, and like magic, the whole problem transforms into something much, much easier, something you can solve with the direct method. Then at the very end, you just swap the original function back in. It's a pretty neat trick, right?
All right, so let's tie all of this together.
We've talked about the right mindset, the tools you need, and the first two big methods. Let's bring it all home and talk about what the real path to mastering this supposedly monster chapter looks like.
You know, when you boil it all down, we're right back where we started with that food analogy. The so-called difficulty of integration is often just an illusion, one that's created by how it's presented. It's not one giant impossible problem. It's a series of smaller, distinct ideas. If you can see it as a collection of climbable hills instead of one giant mountain, you've already won half the battle.
So I want to leave you with this question, because this isn't just about math. How many other hard subjects in our lives are difficult, not because they're actually that complex, but because we just haven't found the right way to look at them yet? Maybe mastery isn't about intelligence or brute force at all. Maybe it's just about finding that one simple analogy, that one clear presentation that makes everything finally click.